Sub-Automatic on behalf of Carlos, Omar, and myself. We'd like to begin our presentation. Okay, so our goal was to create a machine that would fold a sub at the end of a food line. Okay, this is the preliminary drawing that was given to us by our investor that gave us some rough guidelines as to what he had in mind and envisioned for this machine. It was very simple, just two folding channels that was going to be mechanically operated, and you can see the two different views. Okay, so in addition to creating the sandwich, or the machine, he also wanted it to be able to be sold and marketed. So, excuse me. Okay, so this is going to be sold, and based on this, we needed to make it cost-effective, efficient, and safe to be for the masses. Okay. This flowchart represents the current process that exists today in the subways right now. Okay, so you have your customer first walks in, chooses their bread, all their condiments, their meats, and then you have your finished product at the end. What the red line represents is what the actual employee would do in the line. Okay, the green line represents what our machine will do and modify this current line. And then the blue arrows indicate the overall process. So our machine is going to take care of a portion of this line to free up the employee to then be able to service the next customer.
Through
Are we all
our
set?
analysis of the project, we did multi-iterations. The first design you see here is the first conceptual design, artistic rendering of that design. Now, the second drawing you see is more incorporated with the cutting mechanism and a multi-rail system and the undefined attachment accessories, side rails. Now, the second design we went with incorporated, again, the separation rails. We eliminated the cutting mechanism due to safety concerns, but then incorporated a slotted accessory mechanism for attachment. And then the final design, we incorporated a full motor with a simple operation, a pegboard style accessory as a connection, which will facilitate further our modular idea, as well as one rail instead of the two rails shown in previous versions.
Okay, so like Omer said, like he showed before, we had folding channels, and that was gonna mimic the folding of the sub. And we haven't seen a machine that does this out there, so we had to do we knew we had to do a lot of iterations. And instead of sending these parts to a manufacturer and waiting days or weeks to get it back and then getting the wrong angle on the channels that we're gonna fold this up, what we did is we implemented 3D printing. So as you can see here, this is one of the first channels that we did, and the red one is actually the last one. But as we go forward with the presentation, you're gonna see how we incorporated those. So basically, okay. So other parts that we used 3D printing for were the motor covers. What's inside here, the motor cover is obviously the motor and the circuit that we came up with. As you can see, you can plug this into the wall, so it's easy. It's really easy to assemble and disassemble. And again, this motor cover, even though it seems simple, if you would have sent it to a manufacturer, they could have taken a week to give it back, and then it's wrong. So we did about 3 iterations of this one, and the 3D printing helped for that. The picture below, it shows that the actual shaft that we probably use, it's aluminum, and these are the actual bearings that we are going to recommend for the machine, but we're going to talk about that a little bit later. And so that was the shaft. And here we have the railings, we have the bearings already incorporated, the shaft that we showed before, and the belt. It's actually foot safe. So this is what we use for our prototyping. And like I said, we had to iterate a couple times, but yeah. So this is what we came up with for the rails and the belt system. And on the next slide, this is all put together. Like we said, this is the last iteration of the channels that are going to fold this up right here at the end. This is the belt that we obviously had. We didn't get the real belt that we're going to use, that we're going to recommend for the actual product, but this is for a prototype. This is the shaft that we also had to print a couple times to get the right height. and the channels and the ratings that we actually manufacture and that are aluminum. So these are the actual ones that we would recommend for the machine. The motor is incorporated in here, and as you can see, you can just plug it to the wall. So it's really simple to use. And it's all assembled.
Okay, so these two pictures represent our very first revision. You can tell by the blue folding channels. It was the first ones that we printed. On the left, we have our makeshift sandwich that we initially tested with it fully open. And on the right is after it got pushed through the folding channels. You'll notice that there's a big difference in the width. Okay. So here's a little more technical to understand about the folding channels. This is looking dead on down the conveyor belt. Okay, so what we did is our center point here is the center of the conveyor belt, where we then measure an angle from the widest point on the beginning of the folding channel, continue that plane to the same point at the end of the folding channel, and then we measure the difference between those two angles. This is what we're going to define as our folding angle. This concept is looking from top down as a bird's eye view, and what this represents is in order to keep it from bottlenecking, there has to be a smooth transition between the entrance and the exit so it doesn't get clogged up or it passes smoothly through. And here's a video of the first testing.
Okay, so as you saw, we got we're gonna show the actual final prototype later, but that was the first try that we did. We added weight to the sub, and then we run it through and we folded it. This video, what's gonna show is what we recommend for the future of the machine. As you saw on the ratings, we left space for you to add more things to it as you go. So if people come up with cutting blocks later on, or they come up with sealing technology, they're going to be able to add it to the machine. But as of now, this is the concept of how it will be wrapped. The sub will go into a plastic bag. Two sealers with a cutter in the middle will seal the bag that you will take away so you'll get to the customer. The cutter will obviously cut it, and then this seal will seal the bag that will wait for the next sub to come in. So in here we'll have just a whole sleeve of bags, and there's always going to be this seal waiting for the next one, and then the process will repeat. So that way you would eliminate someone from just wrapping at all. You will just place it in the conveyor, and this will hopefully later on be automated and could be added to the machine. But this is just to show the concept of how it would work. Okay, so a little bit of mechanical engineering. That would be nice. So like we said, these are the bearings that we would recommend for the machine. Since the machine, we're planning for it to work for 5 years. We use the hours that it would take for the bearing will take in 5 years. This is the dynamic load. We're going to calculate the dynamic load of what our bearing is going to take in those 5 years, and compare it to the dynamic rating load of the manufacturer. So a lot of things go. It's not just a static load; it's a dynamic load over years. So we have to take a lot of factors into consideration, like application factors and distribution factors. So that's all added into the dynamic load that we're going to calculate. So this right here also we use for a radial load. It's going to be 10 pounds, even though a sub will never weigh 10 pounds. We're just overshooting. And actual loads, we don't think there's going to be any, but we're using a 1 pound actual load. So these are the known factors that are going to go into our dynamic loading calculation. And on the next page, slide. These are other calculated factors like the equivalent load, and and then so what we got was that our dynamic loading rating was 4656. The catalog load is 255. So even though we planned for 5 years and we put loads that were a lot more than what the sub is going to be, and this is running continuously with a sub on top, which with a 10-pound load on top, which is overshooting by a lot. We still had a factor of safety of 548 for the bearings, and this is on the bearing that's connected to the motors, which is the one that's receiving the most load. So this is what we can say confidently that we can recommend these bearings. They're food safe, they're sealed, and they're flanged. So, yeah. Okay, for material selection, We actually got the cost for some of these materials. We had a lot of materials, so we selected the ones that were cost effective, the ones that were food safe, and we recommended that some of the parts were CNC'd and that some of the parts were molded. For all the CNC parts, like we said before, the shaft and the frame are aluminum 6061 that's food safe and it's a strong material, and that's what we will use for our CNC manufactured parts. For the molded parts, the resins that we recommend that are also food safe are going to be there's the acrylic, plexiglass, and remind me what high density polyethylene. These are the ones that we are going to recommend and that we're going to show later how much they cost for mass producing.
Okay, so as Carlos mentioned before, we got our CNC codes. We got them from two main locations. First, the United States and China. We decided to do first cut CNC because they're actually a prototyping company. So we did 100 units and see how much it would cost. Total cost would be $70,000 for the CNC parts with 6061. That's aluminum, and the molds all food grade. That comes out to 33,000. Now, if you notice here, the tooling, the unit cost does not add up to 100 because the tooling cost is actually higher. Good thing about this is that with the molds, you could actually provide up to 5,000 without having to remake the molds with the materials we chose. Now, as a global component, we also looked for manufacturers in China. We decided to just do the CNC parts in China with a manufacturer that one of us has worked with before, and the price, as you notice, is more than half. So for each of the same amount of units and the same cost. Now, we decided our final quote will be all US for one simple reason: the exportation fees as well as the actual turnaround time is quicker with the United States company than it would be in China, and we have more quality control in the United States than we would in China. Again, these are all ISO 9000 facilities. Now, for the simulation, we did a simple loading of 10 pounds per unit, 10 pound-force per unit. So in other words, we fixed the bottom of the rail where it wouldn't move, and each individual slot where the bearing goes has a 10 pound force. And we actually exceed the safety rating of our. I'm sorry, that's what we actually go above the safety rating that we were expecting on our rails. There, and I'll show you in the next slide. Our safety rating of 408 for the aluminum. But we chose aluminum for one simple reason. With the mold, since this is a long piece, with the mold it has a tendency to curve. So it would be fantastic because we would reduce the cost and get us a more reasonable safety rating. However, it's no good if you can't assemble it because of the curved piece. And the shafts as well were made out of 6061 standard aluminum. And again, same fixture as same fixtures and loading as in real life. We had a 10 pound load distributed evenly, and we had a safety rating of 18.5. So again, that's more than enough to support a long life. Now, this is the final revision with the latest updated side panels and everything. So.
For global component, our 3D printed prototyping parts are biodegradable, so that adds to our caring about us caring about the environment and protecting it. Plastic bags that we're suggesting for wrapping are also biodegradable. Also, the machine, when the actual machine we produce, it will actually be used globally, so we would have to use warning signs for other countries and other languages, and also the manual will be in other languages. And the aluminum 6061, it's also food safe, and the sustainability of it is high. So.
Okay, and going forward for this project, we have two additions. The first two are adding the heater, the heat sealing, and the cutter as well. And also a bottom tray to catch any crumbs that may fall. to make it easier to clean. The good part about this is that since we did keep in mind the modular design, it is easy to create further accessories in whatever you should choose to add to it.
I would like to all thank the people on the slide. Dr. Carnegie, thank you very much for all your assistance. Dr. Basil, thank you for your advice and consideration, as well as our investor, Mr. Norman. Dr. Ziccarelli wasn't here, but he said he was going to come to the final presentation, as well as Malika and Rosario. Now, see, Rosario for some reason. Okay, now questions.
First of all, this is yours, huh?
Sure.
Actually, combined. I brought the investor in,
Yes.
and Dr. Basil put it all together for you guys on a day-by-day basis. A good job. So, but I have some questions after that.
Sure, me too. Just a couple of things. Danny, slow down a little bit in the beginning. It's okay. Just with a little practice, I'm sure it'll be okay. I'm just letting you know that. That's fine. So I think you guys jumped in a little too quick in the very beginning. So maybe just take a quick second to talk. If you go back to the very beginning, it kind of been you certainly danced around a little bit. So maybe just think about the order a little bit. You know, I know you guys are kind of finalizing everything right now, but think about the order. I don't know if it's necessarily relevant to put Norman's specific drawing there because it makes it look a little sloppy, especially right away. It might be worth talking about the idea first and then saying, okay, the investor came in and he gave us this initial prototype, right? But just right away, it stands out like, hey, just some napkin drawing or something like that, right? So just, I don't mean don't have it, but maybe not the very first thing that everyone sees is just that simple. Yeah, right. So, you know, you can talk about Subway restaurants are the largest in the world or something like that, I don't know, whatever you want to talk about. When you go to the processing, yeah, so this one, it would be good to take some steps, right? So rather than show all this in one step with red and green and blue, like the same pathway can be there, right? But just no arrows. And then show the arrows as they are now, and show the arrows where Wally or E-Wall comes into play, right? And then show where the savings is, right? So for instance, customer walks in, bread choice fillings, toasted deli style, and then boom, that customer can go, the next customer can come and talk to the associate again, right? I know you guys did a study on that, which is, you know, it certainly would be worth stating. This is typically how it's run, right? There's one person at the register, two people doing the subs. If you can eliminate one of those people for $1,000, that's a really big cost savings. So, you know, I would at the very end reference that again. So you had a design for $700 or something like, what was it, $1,000 or something like that, right? I forget the exact number. Relate that back to a cost savings to the actual customer, which would be the vendor, right? The sub-vendor. So that way, I know this is not a business presentation, but at the end you can say, look, if you just use this and you remove one person, you spend $1,000 on the one device, and it saves you, you can even throw in healthcare costs, all the stuff that you want to throw in there, right? But that makes a big difference in terms of the applicability of your design. So, and then I would say it might be worth, you know, when you're talking about materials and things like that, Omar, you're good with SolidWorks, right? So rather than just have little, you know, tables of things, maybe show a picture of each of the different things and say this will be HDPE, this will be aluminum, you know, again in that part. And say all of this is food safe, this is food safe, this isn't, but you can make it with food safe, blah, blah, blah. You know, so that way, just, it adds a little bit while you're going through rather than looking at tables.
Okay.
For the bearing analysis, it's definitely worth, you guys spoke about it as if you're talking to mechanical engineering design class, you know, design 2 class, right? So I would imagine anyone else who has not taken design 2 class will look at this slide and go, what are you guys talking about, right? So it's great to show the analysis and it's great to show that you did the analysis, but you got to come up with a layman's way of describing that analysis, you know, so FR and FA, what is FR, FA, you know, so maybe it's worth, you know, you have a diagram over there of the bearing, show what the axial force is, show the radial force and what those directions are, so that way people get an impression of, okay, so they're applying this load and they're trying to evaluate length and time that it will actually be applicable, right? And then for aluminum, one more, I guess. So when you're talking about the aluminum in your specific simulations, right? The other reason for using aluminum is that it's robust, and that's the only loading case is not just putting the sub down on it, but the fact that it could fall on the floor and it's anti-corrosive, so you can wash it, you can do all sorts of additional stuff with it, you know, so it's worth talking about those additional benefits. But other than that, I would say just be careful. I know you guys don't like it when we say this, but definitely be careful of font size, because they do get a little small throughout.
Right.
So
Or
you have a whole
color
ton of
schemes.
space. On this one, you have so much space on that slide. Just fill up the space, you know, so that people can see.
Or use colors.
Yeah.
Very good. By the way, you're well under time, so I mean, if you want to add some more substance, bear that
Well, you're
in
gonna
mind.
take it apart, right?
Yes.
So they'll have the device and they'll take it all apart and everything. So that,
We'll show
you'll
them.
have to try to find
We'll
out.
show them what you like.
We're bringing actually some of the earlier
The components?
Yeah, some of the earlier prototypes in.
Right.
Okay. All right, you all done?
I think so, but yeah.
Man, I'm smelling some subs here. None in the room? You guys are bringing us up?
Maybe it's my chips.
All right. Okay, the safety factor for wearability over a 5-year period for the bearings was good. I'd like to see that kind of number. But what about the same kind of safety factor for the conveyor belt? Do you do anything for that?
The conveyor belt is actually made to be reusable. It's the way we actually understood it. It's a thermoplastic. It's only the food-safe thermoplastic that provides enough friction to actually hold the sub. So, but since it is a thermoplastic, it will degrade over time. It should last within a year. We've done studies and research on that. I guess I'll add that to.
Yeah, that'd be worth, because you tension it too, right?
Yes.
So that adds,
Yeah,
that
so-
decreases the lifetime.
So you may want to comment on that,
Right.
that every year the conveyor belt may need replacing. And, okay, yeah, address that, please.
Yeah. Maybe like a yearly cost for maintenance or something like that,
Exactly.
so people know.
Right. There's a lot of reference to SI units. Remember, we have an American audience, so give them some kind of a feel for the conversion, so wherever possible.
One other one, sorry, manufacturer.
Manufactured.
Chores.
Yeah. What's the speed of the conveyor belt, and could that create some operational safety?
It's 1 inch per minute. We could add that to the side as well.
Yeah. And did you assess that against operational safety?
We're gonna add a risk analysis to our file.
Okay. And you addressed cleaning of the crumbs and all of that. What about stuff bleeding out of the sub onto the conveyor belt and all the other systems? How are you going to take care of that cleaning?
Well, that's
So
actually a very good question. We did a little research on the actual first the materials we chose, and as well as the disassembly. You could the size we chose it for two distinct reasons. One, the size available at given subways, and second, the size available at dishwashers, commercial dishwashers use. So what we plan on doing is you could actually put the whole thing in the dishwasher and rinse it out. Obviously, you have to remove the belt, but the whole thing in the dishwasher for maintenance or daily, and then once a month actually take it completely apart and do a more thorough cleaning.
we'll say that as quickly as you can in the presentation, so you
Okay.
can demonstrate that you did take it into account.
Okay.
All right. What if some customers come in and they want their subs heated? Where does that come in the process?
Well, that's actually before you put it in, though. Right before.
Oh, okay.
Yes.
All right. And you're aware of all of the rubric line items as to how you will be evaluated by the IAB? I think I've published that many, many times, so you want to pay attention to that.
We tried to actually search the, previously we couldn't find it.
I emailed it.
No, we tried to. The
No,
website's a
no,
little difficult
it's
to
there.
So check your email.
Okay.
Plus, it's in Blackboard in about 2 or 3 places.
Okay.
Yeah. Have you been reading Blackboard?
Yes.
Okay. Well, it's there about 2 or 3 places.
Okay.
All right. Other than that, good work. Mr. Workman would be delighted to see this. And you're meeting with him soon?
Yeah.
Okay, so, all right. Congratulations.
Thank you.